Hi, we're here doing the tortilla problem. Yes, this is pita bread, but it's the closest we could find. Tortilla problem, the investigative task number 6 on the 2015 AP Stats problem. So, the general background for the problem is corn tortillas are made at a large factory that produces 100,000 of these things per day on each of its 2 production lines. The distribution of the diameters of the tortillas produced on the production line A is approximately normal, with mean 5.9 inches. And the distribution of the diameters of the tortilla, of the tortillas produced on production line B is slightly larger with a mean of 6.1 inches. So, the first question, there's 2 different methods of sampling that you could do, that this factory could do. Method 1 is take a random sample of 200 tortillas from the 200,000 made per day and measure the diameter of those selected tortillas. The other method, method 2, is randomly select one of the 2 production lines on a given day and take a random sample of 200 tortillas from those production lines and measure the diameter of each tortilla.
I know, like, you don't need it anymore. I don't need it either.
Question A that we're going to answer is, will a sample obtained using method 2 be representative of the population of all tortillas made that day with respect to the diameter of the tortillas? Explain why or why not. Can I have the pita bread back? So, the problem with using method 2 and that being representative is if you pick production line A, for example, then the mean of that production line will have tortillas size 5.9 inches. So let's do production line B, 6.1 inches. So let's say we pick production line B, and the mean diameter of the tortillas of that production line is 6.1 inches. So that means that of the sampling distribution, so let's say this is the sampling distribution, let's pretend that's normal, the mean of that sampling distribution is likely to be 6.1 inches. However, if we want it to be representative of the entire population, because as you see in the actual sampling distribution of production lines A and B, the mean of that production line would be about 6 inches. But if we just randomly select production line B, we're going to probably have a mean around 6.1. And if we choose production line A, the diameters are probably going to be around 5.9 inches, which means that we're not going to get a very representative sample of the entire population of tortillas if we only pick one of the production lines. Cool, I answered 1.
Yeah.
So the figure shown here has like a bimodal look to it, meaning there's 2 peaks to it. That means it'd be very unlikely for method 2, which is where only one production line is sampled from, to produce an approximate sampling distribution like this, as that would likely only have 1 peak and be unimodal. That means that it's likely that method 1 was used for this sample, because this sample is bimodal, and it'd really only be likely to have method 1 produce a sample like this that has 2 peaks. So that's why method 1 was likely used. Right?
Question C. Which of the 2 sampling methods, method 1 or 2, will result in less variability in the diameters of the 200 tortillas in the sample on a given day? Explain. So, for question C, the answer is method 2. Because if you did method 1, you would get a sampling distribution that looks something like this, with first peak for production line 1 and second peak for production line 2. And you can see that the mean is here, and then the variability would be high because a lot of the points would not be towards the mean. It's not very normal. But if you did sampling method 2, you'd end up with one of these 2 curves. So if you chose production line A, it would be this one. If you chose production line B, it would be this one. So if you chose production line B, you'd end up with a curve like this, with the mean in the middle, and then it's a kind of a normal-ish curve around it, and it would have a lot less variability. Question D. Each day, the distribution of 200,000 tortillas made that day has a mean diameter of 6 inches, with a standard deviation of 0.11 inches.
Oh my god.
Now, for the question, for samples size of 200 taken from 1 day's production, describe the sampling distribution of the sample mean diameter for samples that are obtained using method 1. So method 1 is the one where they take 200 random tortillas from from all the production lines. So the mean as stated in the past, or I guess you can look at the histogram here, is 6.0 inches. And to find the standard deviation of this, you will take the standard deviation they gave you, which is 0.11, and divide it by the square root of the number of tortillas we're sampling, which is 200. And this will equal 0.00778. And since there are more than 2,000 tortillas produced in that given day, a sample of 200 isn't a problem.
Alright, so question E is, suppose that one of the two sampling methods will be selected and used every day for 1 year. The sample mean of the 200 diameters will be recorded each day. Which of the two methods will result in less variability in the distribution of 365 sample means? Well, it's basically like we've been saying all along. Method 1 will produce less variability in the distributions. This is because samples will be taken from both production lines each day, so the distribution should be different. Method 2 will sample from only one line each day, and this will differ day to day because of this, due to the random selection. This might create a lot of variability between the samples for all of the days. So essentially, you could have one day at 5.9 and another day at 6.1, which will cause for a lot more variability. Where in method